So Earth's atmosphere, and it says that carbon dioxide has changed over time, which row shows how the change has taken place. So if you remember the graph we had in our books, we saw that carbon dioxide started off very high and then decreased to a low level. And the only one that matches that is option D. The actual percentage of carbon dioxide varies today. Give two factors that would cause it to vary. There's loads and loads of different answers here. I'm going to pick the burning of fossil fuels. And if you remember, when we burn fossil fuels, that causes the release of carbon dioxide into the atmosphere. So that would cause it to increase. I'm then going to pick one that would reduce it just to give a different variation of this. So we have got photosynthesis. Okay, and this is where plants absorb CO2, which reduces levels in the atmosphere. You could have had deforestation. So deforestation is cutting down trees, and therefore you would have less photosynthesis taking place, which would cause CO2 to increase. You could have had volcanic activity. Volcanoes release CO2, so that will cause it to happen as well. And just the very fact that there's more people now, so there's more respiration, and therefore you get more CO2 as well. There's 4 marks. So there's 1 mark for each of the factors, and then 1 mark for your little explanation as to why it affects it. Okay, carbon dioxide is a simple covalent molecule. It's got a low boiling point. Explain why it has a low boiling point, and they're giving us 2 marks there. So this diagram here is hopefully the one that comes to mind when we talk about this. You've got your molecule of carbon dioxide here, and a molecule of carbon dioxide here. And inside the molecules, as you can see, I've labeled them here strong covalent bonds. But between the molecules are weak forces of attraction. So what we have to say here is the reason it has a low boiling point is because there are weak forces of attraction between the molecules, and because they are weak, they do not need a lot of energy to break them. Okay, last little bit here is a calculation. It wants us to calculate the number of moles. So all I'm going to do here is let's write down my little triangle so that Mr. Moles is underneath the mass. And we're trying to find the moles. So according to the triangle, moles is going to be the mass divided by the MR. So the mass in the question is 0.11 and the MR is 44, it's telling us. So let me just do that on my calculator. So 0.11 divided by 44, and that's giving me 2.5 times 10 to the minus 3 moles. But the question is asking me to get the number of molecules. So to get the number of molecules, all I'm going to do now is to get the number of particles is to take the number of moles and times it by Avogadro's constant. So the moles is 2.5 times 10 to the minus 3 times by Avogadro's constant, which is given to us in the question. So let's now do that. So times by 6.02, that to the 23, and that's giving me an answer here of 1.505 times 10 to the power of 21. and that's molecules. Just be careful though, because in the question it said give it to two significant figures. So if we just check 1, 2, let's look at the third. So the third one is less than 5. So my actual answer is just going to be 1.5 times by 10 to the power of 21 molecules. 3 marks in there. So 1 mark for working out the moles, 1 mark for doing this little bit, and then 1 mark for giving the answer to the right form.